we had history. If you board with me, then it's your problem. So where is Saudi for a very long period of time? We shall be discussing chemistry, we shall be discussing physics, and I believe at the end of it all, it will be of beneficial. So, Jordan, mainly when you are in class or anybody, you ensure that umemute. Ndio at least wengine wasikie kitu nasema. If you don't mute, then what do you want? You will tell me what you want. So today, let me talk about Hooke's law. Hooke's law, actually, if we were supposed to use another next topic, we would have used springs. So when we talk about Hooke's law, we can talk about springs. Yeah. So when we talk about Hooke's law, it looks like it's another name for a spring. Why am I saying so? Because Hooke's law is a matter of extension, stretching, or compression. And in this case, the best example that we always use is the spring. We all know a spring. We even know the applications of a spring. We have seen a spring. We have given you a spring in the lab, and you have damaged the spring. You know how. I don't know, maneno ya wanafunzi ni gani? I give you a helical spring. Nakakwambia tu vizuri, just see how it stretches, you can compress. But tell me, come after 40 minutes, utapata your spring, I don't know. And you must be here. Kuna mtu ako hapa tu ananisikiza vizuri na anajua how many times amekuwa akiharibu hiyo spring. Si ndio? Anyway, apart from the spring made of a wire, we also have stretching materials. For example, right now, I know, okay, 90% of you are not wearing socks right now because you are in your room, you are, I don't know where you are. Okay, anyway, hakuna ubaya usipofaa socks, mimi sina ubaya na wewe, lakini tukipatana shule kama socks, unajua. So socks pia inakuanga na ina stretch. That's why socks ndogo unaweza uivae vizuri. After some time unavaa socks vizuri hivi, ukiachilia imeteremka chini, inakaa na kiatu huko chini. Unashangaa kwani namna gani tena. So kuna vitu mingi tunaenda ku discuss as to why such socks behave in the same way. Hooke's law. So now it's a that we are going to discuss, and make sure by the end of this lesson, because I must ensure that each topic imeisha. Whether you will go for lunch at 4, whether you will go for lunch in the evening, whether you will go for lunch tomorrow, it must end. Now, number one, everybody must know how to state Hooke's law. That is the first thing, Hooke's law. It's a very simple thing, but everybody must know how to state what? The Hooke's law. Number two, we must be able to explain some of the properties of materials, for example, stiff, brittle, malleable, and others, which I'm actually going to discuss with you during this particular lesson. That is the first thing. Number two, or number three, in this case, you're supposed to know how various springs can be arranged, either in series or in parallel. Are we together? Okay, let me see by the show of hands. How many were there in my lesson yesterday for chemistry? How many were there? Just by show of hands. Thumbs up if there's something I wanted to say. If you're there, I can see some of you are there. Now, listen here. What did we say about a law? You state a law the way it is, the way it should be. Then there is something else that I said. For example, Boyle's law. I said you must know how to sketch the graph. Even for the Hooke's law, everybody must know how to sketch the graph. Yes. Number three, mathematical expression of Hooke's law. You must be in a position to express it. You have to be. Tumeelewana? Then from there, we proceed with calculations. There are a lot of things to be calculated. We will, in fact, kuna maswali kadhaa nimeandaa, and we will be doing the calculation. Are you ready? Can we proceed now? So, Hooke's law. Yes, we will be using some springs. Although we don't have springs here, we will be using the power of imagination. You have to imagine things. Yeah? You have to imagine things. When you imagine, you love to imagine. Together. Yes. So improve, get your imagination ready. Now, why did we decide to use the word hook? Bona, kuna majina ingine ingetumika. It's because the person who pioneered the study of springs, stretching, compression, spring constant, elasticity of the springs was called Robert Hooke. Robert Hooke. Akachukua the hook na akaita Hooke's law. So somebody can ask a question, name the law that explains the functioning of the springs. Say Hooke's law. And you must give us 3 things about Hooke's law. State the Hooke's law, graph of the Hooke's law, and of course, the expression of the Hooke's law, everybody should be knowing. It is called, it is F equals to KE. F is equals to KE. That one is, kila mtu anajua, F is equals to KE. Everybody is knowing that F is equals to KE. So where F is the force, K is the spring constant, and E is, of course, the extension in meters, in centimeters, whichever the case, as long as the units are rhyming. Whereby force is in newtons, spring constant, the SI unit for the spring constant is Newton per meter. But of course, sometimes you can meet with it. Ikiwa in it can be in how do you call this? It can be in Newton per centimeter, and there's no problem with that. As long as you follow all the laws, there is no issue with that. Now, what did Robert Hooke say? But before he said whatever he said, first of all, materials will vary. For example, this shirt of mine, it's a t-shirt actually. One of the most expensive t-shirts around. Nikichukua ingine, you will realize that there is something they share in common or they differ with. Even materials, they differ with the following. So, properties of materials. Properties of materials. You hear some children screaming. Even you, some 5 years ago, you're also screaming like them. But they're just somewhere here. I wonder, last time, kuna mtu aliambia, kuna watoto wanapiga kelele huko nje. Tuende kama unaamua kusikiza watoto patala unisikize. Now, in this case, listen to me. Don't be listening to the noise and of course naysayers. Property number one is strength. When we say strength, what does it mean? Strength. It is the ability of a material to resist breakage. Ability of a material to resist what? Breakage. Kuna material kama hii sahi, nikishika hivi, okay, waje nitumie roller. Hii roller sahi nikitaka kuifunja ni dakika moja tu na itakuwa imebreak because it doesn't resist breakage. Lakini hii nikiamua, okay, hii ndaifunja because mimi niko na nguvu, lakini itakataa, like I have to break it, but nikikupea wewe sifunja, lakini nikikupea hii utafunja. Now, it is the ability of a material to resist breakage. That is the first definition. Then, number 2. Kuna watu wana join class. I don't know what is wrong with them. Why do you have to join class 30 minutes late? Number 2, we have stiff. Stiffness. I'm a stiff. It is the resistance of a material, or it simply means, or it refers to the resistance a material offers to forces which tend to change its shape or size. You try to change it this way in a resist. We say this material is stiff, and if you force it, it breaks. In a resist, if you try to bend in a kata, then if you force it, it breaks. Stiffness. Ukiambiwa na mzazi you are a stiff necked person, ama mwalimu, ujue wewe umefikisha watu mwisho na ukichwa ngumu yako. stiff-necked people. What wakaidi, they are being called stiff-necked people. So that is property number 2. Number 3, we have ductility. Talk about ductility. Ductility. Hey, people are joining class now. Why? Joseph. We're joining class. Anyway, sina ubaya na yeye kujoin class hii. Anajua mahali alikuwa. Ductility. So what is ductility, or what does it mean to say that a material is ductile? It is the quality of a material that leads to permanent change of shape and size. For example, aluminium is ductile. Unaweza change, even copper, you can change its shape because it's ductile. You can hammer it, then the shape changes. Then we have brittleness. Brittleness haiko mbali na stiffness, but stiffness ina resist breakage, but under excess force ina break. Brittleness ina break easily. It doesn't change the shape, it doesn't elongate, it doesn't stretch, it just break. For example, a glass. Zamani before stima ifike kila mahali. The good thing about you is that umezaliwa stima ikiwa kila mahali. During our time, by the way, mimi ndio hata nimepeleka stima kwa village zangu. Sasa nikienda village niombe kiti ya MC ama MB, wananipea wote. Now, tulikuwa tukitumia taa fulani, taa ya mafuta taa, na iko na kioo ya kuipangusa because of the soot. Now, hiyo kitu ule mzazi akikupea, like akiamua it is Timo ndio anataka kupangusa hii glass, you rank yourself amongst the trusted people in that family. Not everybody was given. Very specific people. Kama si mzazi yeye mwenyewe ni firstborn, lakini mostly ni yeye mwenyewe, because the material was very brittle. It breaks easily. So brittle ama brittleness is the ability of a material to break easily because it resists change. Haitaki kuchangewa in a break, because they do not undergo tension. In a break without warning, in a break immediately. Another property is called elasticity. Now, this is where the springs comes in. Number 5, elasticity. Elasticity. Yes. Just a minute, kiddo. Now, elasticity is the ability of a material to recover its original shape and size after the force causing it deformation is removed. Ukiweka hivi, ukifinya, ukiondoa, like most of us, even right now, some of us are already umeingia ndani ya gari leo asubuhi, and kwa bumps umeiona gari ikiruka juu, hata ukufeel like ukusikia anything, but ilikupeleka juu ikakurudisha chini mbele ya bumps, because they use springs that makes the vehicle, move up and down. So the springs move up and down depending on the terrain. Yes. So that is elasticity. So just a minute here. There is something. Be writing those materials. There are only 5. Nikiongezea ingine ndakuwa nimekunini. Let me see these people who are coming late. Sawa. So after it, we have strength of a material, stiffness, ductility, brittleness, elasticity. Those are the various properties of material. So where we have right now, or where we want to discuss right now, is the elasticity. There's a material that when you apply force, when you withdraw the force, it recovers its original shape. Zingine ni kama ugali. Mshakula lunch ama you are about to take lunch. Kuna mwenye ataishika ugali hivi. By the way, kuna formulas mingi ya kula ugali. Unaifinya ugali vizuri, unaimold hapo katikati, unaiunda kashimo, unaweka soup ndani na nyama moja ndani, na unaifunga juu. Na unachukua hiyo ugali unaikula, unaisitoka ndani. Mwingine anashika hivi, anarusha juu na ngoja ifike, na anaishika hivi. Na anaikula. Alafu kuna mwingine mwenye anakula na fork. Very bad manners. Hata ugali ikijua unataka kuikula na fork. Mimi nikipata unakula na fork ugali. Achana tunayo. You will be the worst, but I will not pay for you the bill. You will pay for yourself. Why would you use a fork to eat ugali? A precious food like that. So ukishika ugali hivi ina change shape. Ukiondoa hiyo force, the shape doesn't recover. I mean the ugali doesn't recover the original what shape. Tumeona mpaka so, yeah, lakini spring ukifinya hivi na uachilie, it recovers its original shape. So it is elastic. So ukivaa socks, your socks are elastic. That's why unaivaa hivi inakaa ndogo, lakini ukistretch hivi ukipeleka kwa miguu inatoshea mguu vizuri. Lakini ukiona imefika mahali unaifalisha mguu, unafuta mpaka juu, lakini dakika moja imerudi chini, hiyo pesa ulikuwa umelipa ukinunua hiyo socks imeisha. So what are you supposed to do? Just have mercy. Be a very merciful person. Na hiyo socks, let it rest. Acha itulie bwana, umeoverdo. Sawa. You're overdoing it. Now let's look at this. I want us now to go for Hooke's law. So I want you to write Hooke's law after here. I'm giving you 1 minute. State Hooke's law. I will give you the statement of the Hooke's law. Sasa ukishindwa, just write it fast. You at least when I give mine, ukombee na yako. Sawa. You just compare with yours. So you have 1 minute to write Hooke's law. Hooke's law. Hooke's law. One minute, very fast, write Hooke's law. One 40 seconds remaining. 40 seconds remaining. 40 seconds remaining. 25. 25 seconds remaining. Haya, 15. 10. So, Hooke's law states that for jamani, mimi nataka kuingia class hai. Acha kwanza nimuadd hii kwa class ndio niwaambie. Ama ningewa nini kwanza before ya ingie. Yeah, nakuja late. Sawa. Whoever just come, take your pen, write this. Hooke's law. For a helical spring or any other elastic material. For a helical spring, I can write. For a helical spring, or any other elastic material so the keyword here is for a helical spring or any other elastic material. Kwanza unaweka comma. That is the first part. Unaanzanga hivyo for or any other elastic material. Sawa? Extension is directly proportional to the stretching force. Extension is directly proportional to the stretching force. Weka comma ingine. Extension is directly proportional to the stretching force. Ndio maana jana nilisema hivi. When it is directly proportional, it means ukiongezea force, extension inaongezeka. So extension is directly proportional to the stretching force, provided elastic limit is not exceeded, comma, provided provided elastic limit is not exceeded. Provided elastic limit is not exceeded. That is the statement of the law. Now, because it is F, we are comparing F and E. Are you together? We are comparing F and extension. Now, if we have several materials and you apply the same amount of force, the extension will be different. Why? Because the materials are different. What the difference in these materials is what we call the spring constant. As a K. So now, how will I introduce K in this F that is directly proportional to E? Now, if F is directly proportional to E, meaning the force and the extension are affected by that physical quantity, which is the spring constant, which now will give us F is equals to KE. Can you write this one? F is equals to KE is the mathematical expression of the Hooke's law. The Hooke's law itself is here. Kama tunaendelea kusiri mpaka hapo nipatie thumbs up. Yeah, I hope we are to get up to that point. Yes, thank you for that. Now, ukishafika at that point whereby now ushajua mathematical expression ini, allow me to wrap this, then write for you the graphs. There are two graphs actually. Please, can you, I'm giving you a minute, sketch the graphs of the Hooke's law, two of them. Actually it's one, but the one can be altered to give a second graph. So you have a minute? Just sketch. Nobody will beat you. In fact, nobody will see the nonsense you are writing. Just write. If your brother is there, no worries. I will correct you on the board. Yeah, you have a minute. State the Hooke, sorry, give the graph of the Hooke's law in your book. Kama unajiamini tumia ink pen, lakini kama hujiamini tumia pencil. Ndio ufute. That's why a pencil iko na rubber. Kwani kazi ya rubber ni sini kufuta mistakes. Yeah, by the way, the best definition of a life is a pencil. Unaweka tu hapo. Ukiandika upumbavu alafu uone, kwani hizi ni vitu gani nimeandika? Unaifuta very fast. Now allow me to wrap this for the board. Now let me say, for all the laws which are directly proportional, for example, Boyle's law, Charles' law, pressure law, Atana Boyle's law, Charles' law, pressure law, Ohm's law, Hooke's law, because they are directly proportional, it's always a straight line graph, including this one. Force in newtons, extension in meters. How does it appear? It will be a straight line graph. Straight line graph. Alafu utapata ngulusu mwingine ataweka axis. By the way, there is nothing that I hate like plotting a graph na utaweka axis. What is this now? It looks like an arrow. Yeah, Masai. So if you are this kind of a person, when you wake arrows, wewe inafaa tukupeane Tanzania, usaidie Tanzania to fight for independence. So ensure you put the arrows. It's a straight line from the origin. Are you together? Yes. Now, anytime, listen here. Anytime you see a straight line graph, listen, anytime you see a straight line graph, what question comes down there? Let me see. My plot graph, straight line. What's the first question there? Mnanyamaza ni kama naongea peke yangu, si ndio? Sasa nikisema mtu ajibu swali utasikia niko na shida ya microphone. Niko na shida ya network. Yes, chipu umejibu swali vizuri lakini you have the correct answer. But Kizungu tu ina let down. Ala. Ungejibu na lugha kwenu hii ina ungeko uko sawa. What is the gradient? I'm asking about the answer is the gradient. Now you ask me what's the gradient? Unataka tu nini aje? Tuendelee aje? Sawa. Alan, it is the gradient. So what I'm saying is this, anytime you have a straight line graph, you're told to get a slope. The slope, that is it. Slope, of course, is the gradient. Now, let me ask, for force against extension, what physical quantity does the slope or the gradient represent? Tell me. Please, let's answer. Yes, good. Stephen, tumongelea stiffness of material. Anyway, we in stiff. Anyway, so it is a spring constant. Slope. Spring constant. Can you clap for Steve, everyone? Kuna wengine anashangaa ati nampigia makofi kwani alikuwa na jibu ya nani? Sawa. What is the other graph? The other graph, because there's two graphs, the other graph is we alternate. We alternate we alternate the values on the axis. So hapa tuko na extension in meters, hapa tuko na force in newtons. What does the slope represent? The slope represents the inverse of, in this case, the slope gives us the inverse of the spring constant. The inverse of the spring constant. You know, class me one thing that when the axes are reversed in such a way that on the y-axis we have extension and on the x-axis we have force, then the slope gives us the inverse of the spring constant. Yes, so I think at the point we are okay. Aya, kama tuko pamoja, let me see by your thumbs up, everybody. Yes, I can see we are doing well. Now, let me proceed this way. Proceed this way. Now, what will happen? Look at this. So we have part A, part B, and part C. So let's describe this. Just a minute. So my question is, describe the motion. Oh, sorry, not the motion. Hii ni kitu ingine tofauti. Describe the graph at A, B, and B, C. Yes. Describe the graph at A, B, and B, C. Just describe it. In fact, you can do it on the comment section there. You can just you can write AB. What is there? What can you say about AB, and what can you say about BC? Yes. One minute. Like A, B ni nini na BC kwaje. Of course, I will also ask you to give me the graph, the slope of the graph here, but no worries. Everybody knows that the slope gives us the gradient. One minute remaining. Haya, kuna watu wanasema Steven anasema AB the spring obeys slow, BC spring has reached its elastic limit. Okay. BC elastic limit has been reached. Sawa. AB spring constant. AB ni spring constant. Ryan Soinga hapo kidogo unataka kutupoteza. Sawa sawa. BC it is Emmanuel Mutiani anasema BC the spring exceeds its elastic limit, fine, and becomes permanently deformed. Of course, yes. Now, listen here. AB, the spring or the material, because unless the member spring, but it's the material, obeys Hooke's law. But now BC, the material does not obey Hooke's law. Why? Because elastic limit has been exceeded. Good. That's a nice one. I think now you can get it very fine. Sawa sawa. Hapo mko sawa sasa vizuri. So nataka tuendelee hivi. Before tuingie the springs in parallel and in series. Yeah, before we get to the springs in parallel and in series, let me ask a question. This part. What do you call that particular part? Where now the spring, the straight line starts to deform, or where the exact point where the spring constant, where the elastic limit was exceeded. What do we call that specific point? Somebody? Your part, Apa. What do we call it? I'm waiting for one of you to write for me there. Okay, Chichibu, Manuel. Manuel. Elastic limit. The whole of BC shows that the spring was not obeying the Hooke's law because it had reached elastic limit. Anyway, Jordan Kidinji, you have a point. It is called yield point. Yield point or breaking point. Yield point or breaking point. Yield point or breaking point. Sawa sawa. Now, I want us to get to something else. Andika factors affecting spring constant. Daga twende mbio kidogo. There is a way. Our time is against me, and you have seen, I'm receiving a lot of calls. Factors affecting spring constant. Factors affecting spring constant. Hiyo nitakupea 1 minute. Andika haraka mbio because I'm going to list them here. But before that, can you test yourself? Can you test whether you know them actually? There, usipoandika 5. Tutakosana. Hey, just 5 factors affecting what? The spring constant. And I will explain for you on your behalf, like how does each factor affect there was a problem with the network, but let's join again. Sorry, I think I had lost network, but I've recovered it back. So let's proceed. Sorry for that. But I hope I've given you enough time to list the factors affecting spring constant. So let's continue listing them. So let me now see what you have done. Let's discuss it this way. It's only 5, so I hope you have given more than 3. So number 1, type of material. A, type of the material. Number 2, length of the material. Number 3, so just list them down, I will explain. The number of turns per unit length. Number of turns per unit length. Number of turns per unit length. Number 4, the diameter of the spring. The diameter of the spring. The diameter of the spring. Number 5 is the thickness of the wire, or the diameter of the wire making up the spring. Of the wire making up the spring. Now, if the diameter of the wire making up of the spring, it can be thickness of the wire. Thickness of the wire. Now let me ask a question. First of all, confirm you can see my screen. Confirm you can see my screen. Now let me ask this question. Who had listed all this? Put up your hand. Who had listed all this? So nobody had listed all this. Who had listed 4 of these? At least I can see kuna watu walikuwa wamelist kiasi. Now, who had listed 3 of these or above 3? Nice. Now, who who had listed 2 of these? Spansion Mwangi umereisha hata kama sio Mwangi. Mwangi ana represent wenye walikuwa wamelist 2 of these. Now lastly, who had listed 1 of these? We have the Alan. Now, who had listed none of these? Hey, Alan, unapatikana kila mahali. At least now you have known. So what is there, or what's happening here right now is this. Nataka nikueleze venye kunaenda, like how it goes. How does each factor affect? Hata wewe pia fikiria. Sawa. Hata wewe pia ufikirie vile in affect. Now, number one, type of the material. So we have some materials that resist change when force is applied. Yani when you are comparing, for example, when you are comparing a spring made of aluminium and a spring made of copper, even if all the other factors are the same, length of the material, number of turns per unit length, diameter of the spring, diameter of the wire making up the spring, all are the same, the spring constant will vary. Why? Because of the type of material. Number two, ask yourself about the length of the material. The longer it is, the greater the spring constant. Are you together? Do you know the meaning of the word spring constant? Let me explain. If you want me to, if I can wrap it, let me see by the show of hands. I can wrap this on the board so that I can explain something else. Now, let me ask you this. A material that stretches the most, it easily stretches. Does it have a greater spring constant or a less spring constant? You just put a small force, it may stretch. Does it? Okay, let's say we have two springs. Na ingine hapa. You put 4 newtons in each case. I got 4 newtons. Then this A stretches the most compared to B. Which one is having a higher spring constant? Is it A or B? It may stretch sana, I just stretch sana. You can unmute and then tell me if you have an idea. You have no idea? How would you fail to have an idea? Look here. I don't know whether you can see my screen here. F equals to KE. Are we all here? F equals to KE. Confirm? Raise up your hand if you can see it. Now let's make K the subject of the formula. Like K now is equals to F over E. So K is given by F over E. So how is K affected when you increase the value of E? Remember, E is now the denominator. F remains the same. Then how is K affected when E increases? For example, let's say the force is 20 newtons. Extension is 5 meters, is 4 meters. Then the K is going to be F over E, which is now going to be 5 divided by 4. So it's going to be 5 Newton per meter. Now, what if we increase the extension to 5? If we increase the extension now to 5 meters, then K becomes 4 Newton per meter. So I'm saying this, if you increase the extension, you are reducing the spring constant. Kama umenielewa, clap for yourself kwa kuelewa. Harvey. Harvey ajui maana ya kuraise mkono na kupiga makofi. Like lakini ile siku ndio kutanga kofi ndio utaelewa the difference between the two. Now, you increase the length of a spring. Then you maintain all the other factors constant. Then they create the length, they create the extension, and therefore, what happens to the spring constant? It becomes smaller. Actually, can I define the spring constant in a village? If it comes from the village, it's called which language now? The village language on the banka, layman's language. Spring constant actually is the ability of the spring to resist extension. Ability of the spring to resist what? Extension. Ability of the resist extension. So if you can na ikatai ku stretch ama ku extend ama to elongate, then we can say it has a very high spring constant. Can you hear me? I hope so. Factor number 3, the number of turns per unit length. If you increase the number of turns, you are increasing the extension and therefore lowering the spring constant. The diameter of the spring, you increase the diameter, you are increasing the extension when the force is maintained constant, and therefore you are lowering the spring constant. Thickness of the wire, you make a wire thick, you are lowering the extension and therefore increasing the spring constant. Hapo nimewapeleka mbio lakini hakuna ubaya. I hope umeshikanisha. Sawa sawa. Are we together? Nice. So nataka tuwape examples mbili. Our time is moving lakini usikuwa na shida. We are the owners of time. We can decide what to do with it. I know some of you want to go to the swimming pool. Unaenda kuswim na ujui upthrust force, how it operates. Anyway, let's proceed. The topic is still nice. Hapa mnashikanisha vizuri. Now, given this formula, okay, wacha nipeane swali fulani hapa. Let me give out a question here. A spring stretches. Check on the comment section, on the chat section. Kuna swali nimepeana. Kama umeona hiyo swali, give me thumbs up. If you have seen that question, then we work on it. Have you seen it? Nobody has seen that question? Oh yeah, sure. Most of you have seen it. Work on the question. A spring stretches by 1.2 centimeters when when 600 grams mass is suspended. Is suspended on it. What is its spring constant? Yeah. You can give, you can drop your hands over there. So there's something I'm explaining right now. There's something I'm explaining, then I give a question. So first of all, F is equals to KE, and therefore K is equals to F over E. So we have our extension as 1.2 centimeters. So you can do it in, Newton. Spring constant can be given in Newton per meter or Newton per centimeter, but this one is the SI unit. Newton per meter is the SI unit. So whichever the case, you have your answer. So now let's look at this. What's our F? Our F is 600 over 1000 times 10. We get 6 newtons. I'll give you there. Number 2, what's our E? This is our F. Our E is going to be 1.2 centimeters or 0.012 meters. Is this the same as this? Confirm? Ama nimeongezea zeros. When you divide this by 100, yeah, that is it. So then you apply it here. F, which is 6 over 0.012 meters. So multiply by 1,000 kila mahali times 1,000 times 1,000 here. We get 6,000. We get 6,000 over 12. 1, 2, 3 over 12. So by 12, 1, by 12, 5. So the answer is 500 Newton per meter. So if you don't have 500 Newton per meter, where is here one? So let me explain the concept of series and parallel. Alafu niwape maswali. Are you together? Kama mnakubaliana kwanza, let me see. You have to get the concept first. And I've realized one thing. Most of you don't want lessons here sasapa. Where do you go? Asubuhi mlikuwa 70. Sasa mko 36. You still have a long way to go. Hey, Nini. Hey. I was told by somebody, we were doing some training on etiquette. When you sneeze, you say, excuse me. How now? You are supposed to say, excuse me, before you sneeze. Anyway, sneezing is one of the factors that doesn't knock the door. Just come the way it wants. Hata aina respect atuko na nani. Now, do you know how springs are arranged in parallel? And series. Are these parallel? Raise up your hand and tell me. Don't write. Raise up your hand. Uniambie, nikusikie. Is this series or parallel? Ruben? Ruben? Jameni. Si nimesema you raise up your hand. You have two mistakes, Ruben. The first mistake, nimesema raise up your hand, ukaraise mkono na ukaandika. The first mistake. The second mistake, you are wrong. So kuna hii setup A, then I knew ataniambia ati Mike haifanyi. Then we have setup B. Anyway, kama mtaki kuongea sawa, mimi sina ubaya na mtu hataki kuongea. Write for me on the chat section. Hey, is it in series or parallel? I'm following. So to save time, the arrangement in A is parallel. The arrangement in B is series. Yes, that's the first thing I wanted you to know. Are you together? So I want to explain something, and please be very keen. Kindly listen to me very well, because I've realized we only have less than, we have like 15 minutes to go. And one thing I want you to be very, very keen on, because kuna maswali, I will send it to Madam, the one in charge of the program, so that I atashare na nyinyi. I'm only giving 5 questions to be done, and I will mark them tomorrow. So iko hivi. Kwanza nifunde hata hizi kwanza. If you have one spring this way, if you have one spring, and this spring, for example, in a stretch 40 newtons, and it gives you extension like 7 centimeters. Now, what will be the extension if you have 2 springs in series? Like sasa, tumeongeza another spring hapa, still in 40 newtons. If one spring ilikuwa in a stretch by 7 centimeters, when 40 newtons is placed on it, then when you have 2 springs, what will be the extension? When it is in series, you multiply by the number of springs. In this case, the extension is going to be times 2, 14 centimeters. But if they're in parallel, if it is in parallel, the extension is going to be by 2. You divide by 2. Why? The 2 springs are sharing the weight. So the extension is going to be halved. I mean, you divide by 2. If it is 2 springs in series, what happens is you multiply by 2, 3, depending on the number of springs. Kwanza before niendelee, kama umeelewa mpaka hapo, let me know, thumbs up. I want to give another thing here. I want to explain something else. Now, something else is this. This one applies. It applies if the springs are So mapa, if the springs are identical, it applies if the springs are identical. And in most cases, by the way, utafanya swali alafu examiner pale chini akwambie what is the assumption made here. There are very many assumptions made. One, the springs are identical. Two, the springs have no weight. When they have no weight, we say, what do we say? What is the best exam language to show that a material has no weight? Yes, Steve?
It is negligible.
Yes, it is negligible weight. By the way, even some of you have negligible weight. If you are 40 and below, wewe ni negligible weight. Hata ufai kulipisha fare ukienda nyumbani. Sawa. At some point, all of us, we had negligible weight. Anyway, ni sawa. So, I want to explain something else again. Na hii nayo uishike vizuri. Angalia hapa. Look at this. I hope my springs are well seen, they are visible. Let's label these springs. We can label these springs. Like A, B, C, D, E, and F. Which springs are in series? Which springs are in parallel to each other? So what's happening is A, B, and C are in parallel to each other. D and E are in parallel to each other. F is alone, so we cannot talk about parallel and series. Are you together? Now, listen here. ABC is in series with D and E and F. Like ABC, which is in parallel, is in series with D and E. And D and E is also in series with F. Sawa? If you are told to find the total extension, utaanzia wapi? Hapa. Utapata extension ya F peke yake kwanza. Ukishapata ya F, maybe ya F is 6 centimeters hapa. What about extension here? Hapa. It's going to be 6 divided by 2. You get 3 centimeters. What about the extension pale juu? It's going to be 6 divided by 3. You get 2 centimeters. Then the total equate 2 plus 3 plus 6. You get 11 centimeters. Kama umepata your concept changu, can you clap for yourself? I want also to explain something else. There is something else I want to explain. Na hii ni ya mwisho. Alafu ndio ni release mwende live. Nimeona number ina drop. Tulianza 60, 55, 45, Hey, you people, can you learn to be, yani hata sasa nikiamua tusome mpaka 6 jioni, like we maintain the number, lakini some of you, I don't know, mnatoroka mnaenda wapi? Now this one is very important, and in fact the question I'm giving you right now ni hiki tunataka kuelezea sasa hapa. Bas. Hiyo vitu yote tumefanya, we had one assumption, and the assumption was the springs have no weight, the springs are identical, the connecting bars ni easy. The connecting bars have no weight, but in the event whereby the springs have weight, the connecting bars have weight, what are you supposed to do? Listen, you're supposed to do this. Calculate extension ya F peke yake. Now, if you want to calculate the extension ya D and E, what will be the weight? The weight is going to be W plus the weight of F, because now it has a weight, then plus the weight of this spring connecting bar. Lakini hautaongezea weight ya D and E because a spring cannot stretch itself. That's why we are only using what? W, or the weight, because you cannot add the weight of F to W. Why? A spring does not or cannot stretch itself. Ukifika kwa hii, what will be the weight used here? It's going to be W plus the weight of F plus the weight of this connecting bar plus the weight of D plus the weight of E plus the weight of this connecting bar. Then you use it now to calculate the extension kwa D, E, X kwa A, B na C. That's a very important concept. Umenielewa? Can I give you an example? Dare me. Nice. Nice. So let me share the screen. We can see the screen. If you can see the screen, let me know. Do that question. Okay, copy that question. Chapa screenshot ama copy. Tutaifanya kesho. It's a very nice question. I think I've explained most of the concepts here spring. So mine is just to give you 2-3 questions here kuifanya. So do it. Copy the question. By the way, see you in the evening for malls. I will be discussing malls from 8 to 9. Make sure you are there. Usijaribu kupotea. How many will be there? Yesterday you promised that namu kufika. How many are going to be there? Yes, please make sure you. Who was there yesterday? Anybody who joined yesterday? Okay. Thank you for those who joined. Yeah, see you today again. So unaweza pick a screenshot. No, it's not the same link. Michael Baraza. You just go to YouTube. You search Ambassador Speaks. Ndoi. Ambassador Speaks. Then you find us there discussing chemistry. Are you together? Yes. Otherwise, have a good day. For those who are finished, you can copy that question. Ukimaliza, enda uifanye. Usipostpone at yo stui ndafanya stui kesho. Hapana. Do it now. Why do you have to postpone up to tomorrow? Do it now. Do it now. Have a nice afternoon. See you. Clap for me as I'm leaving.